Hello, Mr. Melo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on confidence intervals, and in particular looking at how you can read a t-table, so a t-distribution table. So if you find this video helpful, consider smashing the like button, subscribing, and let's go. So, depending on the table you have in front of you, it might look a little different. I have in front of me the table that's provided on the AP Statistics exam. So it's listed as Table B in the formula sheet. And you can see I have a little picture at the top. So I know that the areas or probabilities given in my table relate to one side of a tail in this picture. Now, some of these tables will have values for both one and two tails, and it'll identify those for you. This table only has one tail, so each of these tail probabilities or areas, if you think of the area as one, you can just think of as these numbers right along this first row that are the column headers. So if I want 0.02, this would correspond to there being 2.02 probability corresponding to that tail, or you can think of 2% of the area underneath the curve there. You can also relate this back to confidence level. If there is 2% of the area underneath that one tail, then you're looking at 96% confidence when you look at two different tails here. So at the very bottom of that column, you'll see a 96. So you'll have those values there. The other thing you're going to be talking about with the t-distribution is what your degrees of freedom are. So you can see that is the first column in this table, and the different rows correspond to each of these degrees of freedom. So say I have a problem where my degrees of freedom is equal to 12 and my tail probability is equal to 0.01. So I'd be looking at a 98% confidence problem. All I would do is go to the 12 degrees of freedom row, like I've circled here, and then I would circle the 0.01 probability column, or 1% being in my tail. And when I do that, the overlap is going to be my t-value, or my critical value in my problem. So the t-value that would correspond is 2.681 in this case. Now, you're not always going to have the degrees of freedom you want in your table. I did here, but most tables will start skipping at some point. So you can see once I get up to 30 in my table here, it jumps by tens for a while before it jumps almost by more than that. So maybe I'm interested in a degrees of freedom of 55. This time I'm going to want my p-value here to be 0.025. So I'm looking at a 95% confidence problem there. Well, I can circle my 0.025 column. That's no issue. But there's no degrees of freedom row for 55 in this table. So in that case, what you're going to do is you will round down to the next lowest degrees of freedom. So since 50 is the next lowest degree of freedom value in this table, I'm going to circle the 50 row in place of having 55. So this is always going to make sure you are being more generous with your value in a sense. So that would tell me that I would use, for my critical value in this problem, a t-value 0.009. Now, the one last thing I want to comment on, you will notice that there is a row here that has infinity for the degrees of freedom. Well, infinity is not a number, but what this is really illustrating is the higher your degrees of freedom, the closer and closer your t-distribution gets to being normal. If you could have a degrees of freedom of infinity, so as it gets bigger and bigger, it's going to get closer and closer to that normal distribution. So these are just what your critical values would be if you had used a normal distribution instead. So you use the standard normal table to find your critical values. So had I done a 95% confidence interval problem and I wanted to use my z-distribution, I would get a z-score for a critical value of 1.960 in this problem. So you can see how the numbers will differ a little bit. So I hope you found this video helpful. If you did, smash that like button and have an awesome day.